Okay, everyone, we're going to get started today. We're very happy to have Dean Eckles here today. He is a professor of marketing down the street at the MIT Sloan School of Management. Today, he's going to be presenting on estimating peer effects in networks with peer encouragement designs. Thank you.
Hi, yeah, it's a pleasure to be here. I've come to the seminar a few times as an attendee, so it's great to talk to this audience. I'm going to talk about primarily a paper we published this past summer with Renee and Eitan. It's about some particular experimental designs for trying to estimate peer effects in networks. Along the way, I'm going to talk about some other kinds of alternative experimental designs. So the setting that motivated some of this work was that at the time that we did this research, I was working at Facebook before I joined MIT, and we were thinking about how in a networked product like Facebook, the behaviors of individual people are affected by those of their peers, and this is kind of critical to the adoption and continued use of these sorts of services. So there's a lot of reasons that we expect that there's substantial network effects in a product like Facebook. I mean, just the idea that it actually has so many users in the absence of some sort of network effects would be really surprising, right? Part of what we're going to ask here is not so much just about peer effects in initial adoption, which is a lot of what people usually look at, but conditional on initial adoption. How do individuals decide whether to use a particular communication technology to broadcast to people, to consume communications from other people, and also to engage in directed interpersonal communication? And so the idea is that a lot of times these things actually sort of serve as rewards for each other, right? The reason that I want to broadcast to my peers is because they're going to consume what I've broadcast, and maybe that this is going to prompt some directed interpersonal communication as a result, like them commenting on what I've broadcast. And that is part of the value that I get from broadcasting in the first place. So that's sort of the empirical setting for this, is that in particular, we're going to be looking at estimating effects of people receiving feedback in the context of social media. So when somebody shares something, what are the effects of giving them additional feedback, such as likes and comments? The effects then on generating further conversation, sort of in-kind peer effects or generalized reciprocity, where if I receive more comments from my friends, do I give more comments to my friends as well? And then repeating the behavior that got me there in the first place, which is creating and sharing more content in the future. And so the idea is that these are sort of virtuous cycles in the context of communication technologies like Facebook. And so we'd really want to understand how these work, how large they are, what some of the trade-offs are that are involved. So that's kind of the empirical setting for this. So just as outlined in the talk, I'm going to say a little bit about network effects in communication technologies, then how we'd go about estimating peer effects in online social networks, considering some alternative research designs we could use, and then focusing on this design we call peer encouragement designs, and then show you this particular field experiment that we ran on Facebook. So while this one paper on this topic is published, we're continuing work in this area, and so I'm really excited to get feedback both about the more methodological side of this, but also what some of the interesting directions substantively are for this work. Certainly, as I already highlighted, there's a lot of reasons to expect network effects in communication technologies, right? So a lot of the value I get from a communication technology comes from that I can communicate with other people. And so, sort of if I wanted to communicate with everyone equally, if I valued communicating with everyone equally, then the value of a communication technology to me might be sort of order n. I think that's probably not quite right. So, in multi-way communication, sometimes this is called Metcalfe's law. So then the value of the network would be order n squared, because if every person sort of wants to communicate with every other person in the network and gets value from doing so, then you'd have order n squared. I think that's not quite right in that I usually don't care about communicating with everyone equally. So maybe there's only some subset of the people that I want to communicate with. But still, there's a lot of reasons we expect substantial network effects and adoption of communication technology. One thing to note is that actually in the empirical work we're going to do here, it's going to be difficult for us to distinguish network effects from other sorts of peer effects. So peer effects being more general than network effects in this case, where any cases where the behavior of my peers, broadly considered, affect my behavior. And so, a good example of this is like the adoption of Hotmail um, over time. So Hotmail was a free email service that eventually was gobbled up by Microsoft. One of the things that it did is that when you sent emails, it had at the bottom of the email, I'm using Hotmail, this free email service, and you can get your account here, right? So this the adoption of Hotmail was very viral. There were substantial peer effects in the adoption of Hotmail, but it's not clear that there were huge network effects, really, in the sense that people were getting value directly from coordinating on using Hotmail with other people. If I sent you an email that had this link to get a Hotmail account, you presumably already have an email account that is in fact interoperable with my email account. So it's not necessarily that this is being driven by network effects per se, but there are peer effects here. So though I think we're in a way interested in network effects, we're going to have a hard time distinguishing those from other peer effects. So really, we're going to be studying overall, total peer effects in the context of adoption and continued use of communication technologies. Okay. So our goal then here is to try to estimate peer effects. That is to answer questions like, what would the ego do given different peer behaviors? And so how does a marginal peer adopting affect ego adoption? And then what is the effect of receiving additional feedback is the one that we're going to focus on. So if somebody produces something, broadcasts something, and then they get some kind of response back, how does that affect their subsequent behavior? So the ideal experiment here would be basically to directly assign the behaviors of existing peers. So maybe Jamie posts something on Facebook, and then we randomly assign different of his peers to comment or like on his post.
I don't use it.
Well, then maybe this is an even more plastic substrate for my example. So we could, randomly assign some of his peers to interact with him. Okay, that's not usually going to be possible, right? Even in the case of an internet company that is frequently able to run randomized experiments, that's not the kind of randomized experiment that they can run. So we're going to try to settle for things that are a little bit short of this ideal in some way, right? That are not quite directly assigning the behaviors of existing peers. So, first, one thing we could do if we were interested in peer effects and we want to do causal inference, but we don't have an experiment, is we could do some kind of observational estimation of peer effects. For example, by doing some sort of high-dimensional propensity score adjustment. So we could look at cases where people post things and then receive varying amounts of feedback, model selection into that treatment of receiving varying amounts of feedback using potentially a large number of covariates, and see how well, what that tells us about the effects of feedback. So we actually did something somewhat similar in a different setting where we evaluated these kinds of high-dimensional adjustment methods for peer effects in the context of link sharing on Facebook. So if a friend posts a link, how much does that cause you to post the same link or repost the same link? And so we were actually able to find that if you don't adjust, you have huge amount of bias in estimating these peer effects. But once we adjusted for thousands of covariates using propensity score modeling, we were able to end up with less than 30% bias and actually statistically indistinguishable estimates. So in some cases, it might be the case that observational estimation could be a good approach to doing this. Yeah.
Just a question. Does this compare to some sort of experimental benchmark, or?
Yeah. So in this case, we had a randomized experiment where we randomized exposure to links that friends had shared. So we have an experiment that estimates an average treatment effect on the treated, and then we're able to use that as a baseline to compare these various observational estimators using an additional non-experimental control group. Yeah. So that could potentially work. But I'm going to focus here on experimental designs that we could use to estimate these sorts of peer effects, especially because, in this case, we had this experimental gold standard, and so we were able to say at the end of this, oh yeah, that worked pretty well, and if I was going to do this again with something similar with these same sorts of adjustment variables, I would maybe be confident in it, right? But moving into a new setting, who knows how far off our observational estimation might be. Might not be quite as promising as this case. Okay. So another approach, and this is what our colleagues in like psychology do a lot, is to randomly assign the behaviors of inauthentic peers. So rather than assigning the behaviors of your actual peers, we can assign the behaviors of your inauthentic peers. We bring you into the lab. There's a bunch of other participants, and we say, okay, which of these lines on the right, 1, 2, or 3, is the same length as the line on the left? Everybody else in the room gives totally crazy answer, like it's the first line, and then we see whether you go along with it. And actually, everybody else in the room is our stooge. That used to be the technical term applied to these sorts of people. Now, I guess they call them Confederates. But so that could be an approach here. Obviously, that's going to be limited in trying to understand something like the virtuous cycles in an online communication setting where people care about interacting with their actual friends, and we're trying to get sort of realistically sized estimates of how big these loops are. Another approach that's been common is to assign individuals to new peers. If we randomly assign people to groups or dyads or networks, then we break some of the confounding due to homophily in edge formation. So that could help. That's usually not going to answer some of the questions that we care about in this particular work. One thing that we've done a lot, and that makes sense in the context of online work, is to somehow modulate, randomize some particular mechanism for peer effects. So usually it's the case that the reason that I'm affected by peers' behavior is because I'm somehow exposed to some trace of their behavior. I directly observe their behavior is communicated to me in some way. And so if there's a sort of a small number of mechanisms via which that behavior is communicated to me, then maybe in some cases, the experimenter can randomize whether those mechanisms are active or not. So to make this more concrete, the idea is that we could be randomizing whether peer adoption is communicated to the ego. And this works better in some cases than others. So one case where we looked at this was in the context of personalized social cues in advertisements. So here we have the same ad, but on the left we're showing this aggregate social information, the number of people who like the History Channel, whereas on the right we're showing a particular friend who likes the History Channel. And so the idea is that this particular little message right here is one of the mechanisms via which the peer behavior of liking the History Channel is communicated to the ego. And so to the extent that we can randomize exposure via this mechanism, that can allow us to learn about peer effects. One way of visualizing this, I know that by putting up some DAGs, I'll be really popular here. So basically, one way of thinking about this is we're interested in effects on some outcome, yi, for the ego. There's a bunch of behaviors of their peers, w. These could be the same behavior with some time lag, but not necessarily. And then those, we're saying those only affect the ego via some particular mechanism, right? So the peers engage in some behavior. How does that affect the ego? There's some kind of way that's communicated to the ego, and we can either enable that mechanism or disable that mechanism. And so here we sort of visualize this with all of the mechanisms enabled. So in this case, the mechanism is deterministic. So if the peer if the peer engages in this binary behavior, then that binary behavior is communicated to the ego. But on the right here, we've disabled some of the mechanisms. So only some of the peer behaviors are being communicated to the ego. So to think about that in that context of that example with the advertisement I just showed, we could think of that as a simpler case where maybe there's only a dyad involved, but either this mechanism whereby the peer behavior of liking this page is communicated to the ego via this particular mechanism in the ad, or not. So if the mechanism is actually deterministic and exhaustive, then this kind of experiment identifies an average treatment effect on the treated. Unfortunately, the mechanisms that one can randomize are rarely deterministic and exhaustive. So usually there's a lot of ways that I can be affected by my peer's behavior, right? So in this case that we just considered, my peer likes the History Channel on Facebook. I can get exposed to that through an ad that mentions that. They could tell me that. They could reshare something from the History Channel, and that's another causal path for that to affect me. They could invite me over to their house to watch Ancient Aliens, and then after seeing how great Ancient Aliens is, then I would also like the History Channel. So there's a lot of potential mechanisms. So obviously this is only going to tell us about the effects via that one mechanism. And then also, to the extent that the mechanism is actually deterministic, such that the peer engaging the behavior always results in it being communicated to me, then usually those are precisely the situations where we're not in a position to randomize that mechanism because there's some sort of quality of service guarantee built into it, right? So in the case of this advertising setting, right, the service provider is making no guarantee that if you have a friend who likes the History Channel, their name will always be shown in the ad, right? So we can randomize it to not show that. But in other cases, when Jamie's just posted his photo and somebody comments on his photo, the service provider has kind of made a guarantee about determinism, that when somebody comments on his photo, that will in fact be communicated to him, right? So that means that in those settings, it's not necessarily going to be possible to randomize that mechanism. Yeah.
So can you go to the deck? I'll help your popularity. So when we've studied this sort of manipulate the mediator in order to identify something about the treatment effect or the mechanisms involved, the other thing that was important was an exclusion restriction assumption on the effect of E on Y.
Yeah, right. So which is sort of visualized here, right? Yeah, yeah. Mm-hmm. Yeah.
Does that, I mean, in your context, have you found that to be plausible, or?
Yeah, so I think in this case, that's quite plausible, right? In other cases where maybe the mechanism is, also these cases where there is an expectation that something's going to be communicated. If it's not communicated, people may take action to communicate it via other means, right? If you comment on Jamie's post and then he doesn't notice it, you might try to contact him some other way, right? So I think also those kinds of cases are, again, ones where, that exclusion restriction starts to be less plausible, basically. Yeah. Mm-hmm. Okay. So, one example where we did think this was useful is in this advertising case. So this is just a sort of a brief section of this experiment that we ran in 2012, where we randomly assigned a whole bunch of user ad pairs to either show this social cue or not. So these are all user ad pairs where that user does have at least one friend who likes the thing being advertised, so you could show this social cue. And so either we randomize them to this condition on the right or to the condition on the left at the level of a user ad pair. And so then that allows us to identify effects of showing these peers, effects of these personalized social cues. So this is identifying peer effects that are average treatment effects on the treated for this one particular mechanism, which is not an exhaustive mechanism. So here, if you have one peer who likes the page being advertised, and we go from not showing that peer to showing that peer, that results in about a 10% relative increase in how many people go on to like the page, right? So one of the things to note is that actually just looking across these panels, as you have more friends who like the page being advertised, even if we don't show the personalized social cue, the response rates are going up, right? And this reflects things like homophily and other sources of heterogeneity between people who have differing numbers of adopter peers. And it's sort of a reminder of why we're kind of doing this experiment in the first place, is that things are really dramatically confounded here otherwise. So it's these contrasts within these panels. The case of not showing the cue is showing the cue that are informative about peer effects via this minimal social cue, right? But again, why this is possible is that this is a case where this mechanism is non-deterministic. There's no sort of quality of service guarantee associated with this mechanism for peer effects. And some of these other things apply as well. Yeah. Okay, so the approach we're going to instead use in this context of feedback, we've just sort of highlighted why maybe these mechanism designs are appealing, but they are not applicable when we have this kind of determinism and quality of service guarantees. So what can we do in those sorts of cases?
Why isn't there sort of a pseudo concern in that, like, the names you see could depend on who else has liked it, which could be affected by the treatment?
Right. So there could be some sort of nuisance interference present here, is maybe what you're asking. So yeah, definitely there could be some nuisance interference. Now that's how much of a nuisance that is depends on what you're trying to estimate here. So one question would be, is this telling us what would happen if we decided everywhere not to show personalized social information, right? Does that tell us what happens in equilibrium when we do that? No, not really, right? But it may tell us about what happens when we choose not to show particular social information that's a small change to the status quo. But yeah, you could be worried about some of the interference. One of the things that's to note about this case, though, is at least the interference it would be really localized because all the randomization is at the level of user ad pairs. So an individual user is not dramatically affected by this randomization because the vast majority of the ads that they're seeing are not affected by this experiment, and then a small fraction of them, are potentially in some of these non-status quo conditions, the zero conditions here. Yeah.
Can you just back to the DAG real quick? I just want to get a sense of what you're thinking about this is. So these WIs,
Mm-hmm.
is the idea that
That's some peer behavior, basically. Yeah.
and is it different? Are those different peers or different behaviors?
Different peers. Yeah. Mm-hmm.
But it's all the same.
Right. In this particular case, we're thinking this is the binary behavior of liking the focal product or not. So in the example I've been using, the product is the history channel. Though in that experiment, we actually averaged over 1 million different types of ads. But so it would be whether each of these peers likes that particular product, and then whether that peer is shown in the ad or not.
And so when you're saying the mechanism, it's just like by this particular action is being conveyed to this particular person.
Right. So here the mechanism is really this right here, right? That one of the mechanisms of peer effects is that in liking pages on Facebook is that sometimes people's names appear in ads. Yeah. Mm-hmm.
So in terms of causal pathways, we're blocking the path that's person 1 naturally affects the behavior of person 2, and person 2's behavior is then communicated to me. So it's like a controlled effect for if we were to atomize each individual, ignoring whatever interactions they have, and randomly vary exposure. So is that kind of how I should think about these effects?
Right. Yeah. I think that's correct. Yeah. So that we're sort of randomly disabling some of the exposures that would occur otherwise.
But some of what you're disabling isn't the behavior of person 3; it's the behavior of person 1, which affects person 3.
Yeah. Well, so to be clear, right now I'm only imagining. I mean, we could imagine this with only two people, right? If we just look at one row of this, right? We have this one peer. And then whether that peer's behavior is communicated to the ego, that is whether we say that peer likes this page. Okay, one constraint here is, right, we're only saying truthful things. There's no deception involved, right? So, and that depends on whether that mechanism is enabled, and then we observe some peer behavior, which could be sort of an in-kind behavior, right? Like it's somehow related to this peer behavior, or it could be some other behavior like clicks or purchases or something. In the example I just showed, it is sort of the in-kind behavior in that it's the focal person liking the same product that this peer liked. Mm-hmm. Right. So, I mean, I think this kind of approach has been used a bunch in online settings because you often have control over how the behavior of peers is communicated to an individual. But I think that is really limited to cases where you don't sort of have determinism in the mechanism such that you have a kind of quality of service guarantee that you always enable the mechanism, right? And so in these cases that we care about, like the role of directed communication in driving continued use of a communication technology like Facebook, these aren't really going to be as applicable. Yeah. Yeah, definitely. Yeah. So I don't think I have the slide right here, but in fact, if you take a look at this paper, which is social influence and social advertising, we also examine these effects by tie strength and do find a larger increase for higher tie strength peers. Also, in some ongoing work, we have cases where we have multiple peers available and we randomize among the multiple peers. Considering both tie strength and similarity on a lot of traits, both of which end up mattering a lot for the effects of these cues. Mm-hmm. Okay, So, so an alternative then is going to be to, instead of what we've considered so far, is to indirectly affect the behaviors of existing peers. That is, to randomize some kind of a shock to peer behavior that will allow us to learn about the effects of these peer behaviors, these peer effects. So the idea is that we randomly assign vertices to some encouragement to a behavior of interest and see how ego's outcomes vary with these peer assignments. And so these kinds of designs, especially in disjoint groups, have been widely used a bunch in development, political science, and labor economics. And then sometimes people do similar sorts of analyses where they have some other kind of non-randomly assigned shock that they're going to use as an instrument. So the goal here is to actually estimate the effect of the peer behaviors, not just the random assignment to this encouragement. So basically, the idea is that we're using the peer encouragement as an instrument for the peer behavior. And so I'm going to go into more detail about this approach, and then also some of the kind of experimental design decisions that we made to make this as plausible as possible, basically. So just a very quick review on sort of encouragement designs, not in networks. An encouragement design is a case where we are randomly assigning units to some encouragement Z to a focal behavior D. So we randomly assign students to be encouraged to study or not. We can't determine exactly how much the students study, but we can sort of encourage them or not. We can assign them to take a drug or not, but they might take it anyway, especially say if we're trying to study the effects of aspirin. We could have two-sided noncompliance because some people are taking aspirin all the time and some people don't take it even when we assign them to. And so, yeah, you can analyze this in terms of potential outcomes, looking at just the total effect of the encouragement, sort of the intent to treat analysis, which would be interested in summaries of this difference between people's outcomes when they're assigned to the encouragement and not. But often what we're really interested in is the effect of the behavior, the effect of D on Y, which is we're going to be interested in some sort of summary of these differences between the outcome when somebody engages in the behavior like studying or taking the drug versus not. And so the idea is, can we use Z to actually estimate the effect of D on Y? And I think probably many of you are familiar with the answer being yes, kind of. We don't have fully non-parametric identification, but this can still be useful. So that's sort of the basic encouragement design setting. So we're just calling these peer encouragement designs because we're doing this in the network where the encouragement that we're interested in is one that somebody's peers are assigned to. And so, back to kind of this picture where we have an individual person's experience using something like Facebook. One way of doing this randomization is sort of everyone gets a coin, flip a coin, decide whether they're in treatment or control, whether they have some particular change to the site, like maybe some redesign of the news feed here. And then for this focal individual, we might then look at, okay, how many of their peers, these people I've highlighted in yellow, were assigned to this condition, which maybe encourages a particular type of behavior. And so then we could look at the spillovers from these peer treatments. So when this encouragement is just sort of defined at the vertex level, we could say, okay, what really matters is how many of your peers are assigned to this encouragement. And so we can now analyze the ego outcome as a function of the number of your peers assigned to the encouragement. There's going to be a bunch of sort of nuisance issues here in terms of probabilities of assignment, which depend on degree and other things. But that would just allow us to estimate these spillovers at least. And so we could create some variable like VI that's just the sum of the number of the sum of your how many of your friends are assigned to treatment. Okay. So actually just even detecting to get into those nuisance issues, even analyzing that kind of a setting to say, okay, do my friends' treatments affect my outcome? It seems like this would be kind of an easy question in a lot of ways, but the fact that this is happening in a network where maybe we essentially have a single object, we have a single giant component, can complicate this a lot. So our statistical inference would sort of need to account for something like the network autocorrelation in regressors, where here it's network autocorrelation in the number of your friends who are treated. So there's a few different ways to do this. I mean, randomization inference is certainly one approach. So either doing randomization inference, specifying some kind of sharp null hypothesis, and also a sharp alternative hypothesis, where we think that somebody's outcome depends on their own treatment assignment and maybe other people's treatment assignment. Okay, so this is the null, so it doesn't actually depend on other people's treatment assignment, just depends on their own treatment assignment. There's also this alternative where it depends on their own treatment assignment, but maybe also on the treatment assignments of their neighbors. Here, A is the adjacency matrix. And so in this case, as long as these hypotheses are all sharp in this way, we can, that is that we've assumed constant effects in this particular model, we could use randomization inference to test for these spillovers. It's also possible to sort of imagine an artificial experiment in which we do conditional randomization inference as a way of not assuming sharp null hypotheses. So I'm not going into a lot of detail on this because I think many of you have probably seen this Hito or Susan present this paper that's forthcoming in JASA about doing randomization inference in networks without making constant treatment effect assumptions. But the general idea is that often when we do randomization inference, we condition on some features of the treatment assignment vector Z. So the most basic case is, say I did an independent randomized experiment. That's for each unit I flip a coin, decide whether they're in treatment or control. Then when I do my randomization inference, when I'm doing a permutation test, I might in fact do a permutation, which would thus hold the number of treated units actually fixed. So I'm conditioning on the fact that my treatment vector ended up with a certain number of treated units. Similarly, we can do this to test these kinds of non-sharp null hypotheses, like, oh, there's some direct effects of treatment, but also there's some spillovers. And so generally what we do is condition on some units ending up getting the same treatments as we observed, such that our null hypothesis conditional on those features of Z is now sharp. So I'm not going to go into a lot of detail on that, but it's basically, it is possible to sort of test for these spillovers exactly using randomization inference, which is nice because besides those sorts of approaches, there's a lot of complications about how to do statistical inference in networks, what even the relevant asymptotics would be. So some sort of finite sample, finite population inference is really appealing here.
Can I ask it? So,
Yeah.
What are some, beyond being able to deal with the constant effect assumption, what are some limitations of that approach? I mean, are there other things in this that this would then break down under, or is...
You mean doing this kind of thing, or? Yeah, so I mean, I think, the constant effect assumption can be pretty important, especially as you start trying to test things like higher order spillovers or spillovers via some ties but not others, because now you're not just worried about sort of, this binary treatment that's my own treatment and whether I have that correct or not, whether that's really a constant effect or not. But now I'm worried about whether I have the functional form correct for, say, the number of my close friends who are treated, right? So say I want to test whether the treatments of my acquaintances affect my outcome.
So you're having to essentially then just put a model on top of that with some parametric assumptions.
Mm-hmm.
But it's not just the functional form of the effect of your peers, but it's also like you're sort of implicitly having to take into account which of those peers are more important, right? So you have your A, but then that's an adjacency matrix. But I mean, I have a lot of friends, but
yeah,
I don't really have a lot of friends.
Yeah. Yeah, right. So here, this alternative hypothesis, which then, if we actually were really trying to, so I mean, we could certainly test whether this null hypothesis is true using randomization inference, and we might say, oh, actually, no. Given some test statistic, maybe a test statistic that we choose based on this model, we can reject this model, but it may be that we can reject it for a lot of reasons, including there not being constant effects. Then say we were interested in testing this model as our null against some other model that had a separate beta for your close friends and for your acquaintances. Well, then we might reject this model not because of something about close friends and acquaintances, but because of something about heterogeneity in these spillover effects. So yeah, that would be kind of worrying. I think many of the same sorts of ideas are probably apply here that come from the rest of sort of work on randomization inference and permutation tests, right? Like Chiang and Romano have these results that if you use the T test statistic in a case like this, then asymptotically it has the correct rejection rate, not just for the null of there being no difference in the two distributions, but the null of there being a difference in means in the two distributions. So I think in practice, probably if you end up, if you think that somehow you're in an asymptotic regime, then if you're using a t-statistic or something like that, right, a score statistic, then maybe this isn't going to matter that much. But I don't think we have really much of an idea of how quickly a lot of these asymptotics are supposed to kick in the network setting. So I think that'd be an interesting thing to look at.
So W here is a W without the I is a vector of
Everyone's treatments. Yeah. Yep. Okay, so this is just sort of to mention that even this case of trying to say, okay, is this individual affected by their peers' treatments is not trivial, but we can do that. And also to point out the fact that a lot of the reasons that it's complicated and a lot of the variance in this estimate is going to come from the fact that treatment assignment or that individuals are assigned to a treatment, and then this variable that I care about, which is the number of peers assigned to the treatment, that's going to be hugely autocorrelated in the network, right? So the number of peers of my peers that are treated is going to be correlated with anybody who I have mutual friends with, right? So so that produces a lot of correlation in sort of the key regressor here, right? And that's essentially what one is trying to cope with through this randomization inference, and also through other methods you might try to apply here. Okay. So this is just in case we wanted to detect that the peer treatments are affecting the ego. But part of what we want to do is actually to estimate the effects of the peer behaviors as randomly induced by this encouragement on the ego. And so I think I'll kind of skip over this. But the general idea here is here we have a slightly different DAG than what we were looking at before. So again, we have the ego behavior that we're interested in, yi. Then we have the peer behaviors, w, that we're interested in. And now instead of intervening on something that comes between w and y, we have this instrument z that's this randomized encouragement to the behavior of interest. And so here, any given person is going to have a mix, in the case of a binary behavior, potentially a mix of complier and non-complier peers. So here on the left, we're looking at this example case where we've encouraged all the peers, and so 3 of the peers adopt the behavior. Whereas on the right, we encourage none of the peers and 1 of the peers adopt, right? So we had 2 compliers and 2 never takers and 1 always taker here, right, among somebody's peers. So just in trying to understand when we have something like this kind of shock to peer behavior, what sort of quantity are we going to end up estimating? It's going to really depend on things like the correlation in the network of who's complying with this encouragement and who's not.
Is this going to allow you to pick up, or do you care about whether some of these W's are like popular or more influential than other W's? Like it seems like averaging over all those YIs, like you might lose some information about particular individuals who are very influential in the network.
Right. So I mean, we might really want to not just look at how many of my peers are treated, but how many of my important peers are treated. And then once we're looking at the behaviors, we might want to know, whether some of my close ties or other people are induced. So some of that's going to depend probably on the experimental design, exactly how I set this up. So we'll get to that because some of the follow-ups that we're going to do are an attempt to try to estimate those effects. Yeah.
I have a question. So how do you decide who is an ego and who is a peer? Like, because I imagine that you start from a graph with a set of vertices.
Right.
How do you choose which one to treat and which one?
Right. So part of the idea here is everyone is an ego and a peer potentially, right? So I'm using ego just to be some focal individual that we're talking about right now, but in many cases there's going to be a lot of sort of symmetry where, and this is why we're sort of worried about a lot of the dependence as well, right? Is that I want to analyze this person's outcomes, but also this person's outcomes, and so the way that I do that needs to account for dependence in treatment assignment, dependence in assignment to this measure of peer treatment, and maybe additional dependence in the outcomes. Yeah.
So the encouragement is completely at random.
So in the design I've described so far, it could be something like that we're doing, completely completely randomized or an independent experiment would be more common in a large N kind of setting.
Why not sample the egos just sort of far apart in the network?
Right. So you could potentially do that if you think there's such a thing as far apart in the relevant network as you get a relatively large sample size. So in the example I'm going to show you, we analyzed data for 50 million egos, and essentially that means that their peers include everyone in the Facebook network.
Why do you need 50 million observations? Why don't you do it with 2,000?
Yeah, okay, we'll get to that. Power is one thing. So actually one of the things I just mentioned already is this idea that because this number of peers treated is going to be correlated in the network, that has huge consequences for power. We're actually going to try to avoid that in some other ways as well too. Okay, so just to move on a little bit more here. So in this case that we've been looking at so far, we could do something like, the ego's outcome is assigned by their own assignment and then peer behaviors, and then we do this sort of IV analysis where we need to make some sort of complete mediation or exclusion restriction assumption that basically the peer's treatment assignment only affects the egos via the peer behavior. And I'll skip over that a little bit. So the cases that I've described so far look like this, where we're assigning vertices to some sort of undirected encouragement, right? So that we, encourage people to enroll in a retirement savings account, right? And we're going to be interested in how your peers enrolling in an entire retirement savings account affects your choice to enroll. We could encourage people to post a thankful status update on Thanksgiving Day on Facebook, right? And I think, on Thanksgiving Day 2010, actually 1% of Facebook users were randomly assigned to have an alternate prompt here. Instead of this prompt saying what's on your mind, it said, what are you thankful for? And so you could imagine then counting how many of your friends were assigned to this alternate prompt, using that as an instrument for the number of friends who posted a thankful status update to estimate the effect of exposure to friends posting the thankful status update on the ego. Or we could imagine in our current setting, we could encourage vertices to comment more on posts by all peers. And so then we would summarize how many of your peers are assigned, what your peer behaviors were, and compute the average ego behaviors as a function of those. What we're actually going to do is a little bit different than that. And so what I just described is this idea where we could say for a given individual, we're going to assign them to a condition that will encourage them to give feedback, that is, to give comments and likes to everyone whose content that they see. So it'll encourage them to give feedback to all of their peers. That would be sort of this undirected design, right? That we'd analyze just as I described. An alternative is to instead assign posters, people who've just produced some content. So Jamie just posted a photo, and then we could assign him to a condition encouraging his friends to give him feedback, or he could be in the condition where they're not encouraged to give him feedback, right? So that's a bit different because actually the way that works is that his friends could be assigned to different conditions with respect to different people, which can potentially break a bunch of this network autocorrelation in the relevant regressors and substantially increase our power. You could even imagine, sort of along the lines of what you were asking about, a design that assigns particular directed edges to an encouragement to feedback in that direction. So you could imagine, right, and that's sort of what we visualize in this picture, is that we can assign particular peers to this behavior, and you can imagine actually adding an I subscript on all of these as well, so that these are pair specific. So we could actually encourage specific friends of Jamie to comment on his post and not encourage other friends, right? Okay, so just to make this more concrete, how are we encouraging people to comment on posts? So here's a post by my co-author, Eitan Bakshi. It's the exact same post at the exact same time, displayed in two different ways. On the left, the existing feedback is expanded below the post, and the text box that you would write a comment in is already open and has your profile picture next to it. In this case, this is a screenshot by Eitan, so it has his own profile picture. And he already commented on his own post once, so it's a popular post. Okay, so this post already has been liked by people, and it already has this one comment from Eitan. So either we can expand all that information, right, or we could summarize it here, right? And depending on how Eitan's post is displayed to other people, he's going to receive differing amounts of feedback from those other people. That's sort of the fact that I'm going to provide evidence for in the future. And so what's different about this than the designs that I described before is that everyone, we're still randomizing everyone to a condition, but what that condition does, if we think about this focal individual here, is it's controlling how other people are experiencing content produced by that person, and it's specifically encouraging interaction along these directed edges, right? Whereas the designs we were thinking about earlier encourage some sort of undirected behavior. And so instead, in this case, we just keep track of, for each individual, are they assigned to a condition that causes their peers to be encouraged to interact with them? Yeah.
Isn't it the case that stuff that's getting interacted with is more likely to be seen? Is that right? In the
Mhm.
Facebook design of
Right. So there could be some sort of algorithmically assisted herding effect, is what you're thinking about. Yeah.
If it were the case that everyone's actually seeing the post or more people are seeing it because the way that Facebook has designed it, that's affecting where it's showing up on the newsfeed or something like that.
Mhm.
Part of the effect could just be driven by that design.
Right. Though it's worth thinking about what's downstream of showing it in a different place in newsfeed, right? So if you post something and then I am induced to like it by this encouragement, and then that causes it to show up higher in Dustin's newsfeed, then what's the consequence for you? The consequence primarily is going to be that the Dustin's going to interact with your post. So it's still potentially satisfying this exclusion restriction. Okay. So basically, our design recommendations in this setting, and this is sort of what we implement, is to try to avoid randomization of vertices to these sort of encouragements to undirected behaviors, and instead randomize individual edges or randomize a whole ego, but to a treatment that affects only the edges that are directed at them. And this sort of breaks this network autocorrelation and random assignment, and we show through a bunch of simulations that this can hugely increase statistical power. And then the other part of this is that we want to use the most minimal encouragement possible given the sample sizes. And so, Gary, I think this is going to answer your question, because we'd really like to estimate the effect of some sort of marginal peer behavior, right? So these peer behaviors that might occur or not depending on small policy changes. And also, we want to make our exclusion restriction really plausible. The idea that this encouragement is only of your peers is only affecting you via specific peer behaviors. And one way to make that really plausible is if sort of this encouragement is a feather touch nudge that is not going to result in reactance or other types of responses to that nudge besides the specific behaviors that we're interested in. And so just to say a little bit more about our actual experimental design, sort of what I described before is that we're going to randomly assign egos to have their posts shown in this conversation salience high thing, which affects what posts when they already have feedback. So do we show the existing feedback and do we open this comment box, or do we summarize it here? Note that actually the feedback is still one click away. In fact, it's still the same number of clicks to like and comment. So if you click comment, it opens that text box and puts your cursor inside of it. So this is really a pretty light touch encouragement. For posts that do not yet have feedback, we just have this encouragement that consists of either opening this text box or not. And we have this status quo that was sometimes, which is sort of a, we can discuss more if we want. So actually we have a 2x3 experimental design where we're assigning egos to conditions that control how their peers are viewing their content. So this experiment was conducted in 2012. We're going to analyze data for 50 million egos. So these are users who had created at least one post prior to the experiment or during the experiment. So they actually were eligible for this to be affected by this change. And they had at least one friend who had used Facebook on the web, because this change only affects how the posts show up on the web.
Even with the last slide, why do you need 50 million observations?
Mm-hmm.
Because you can, but why do you need them?
Yeah. So let's look at the first stage of this estimation. So here we're looking at the effects on receiving feedback. These are the effects of our treatment assignment, of our encouragement on you, whether you actually receive more feedback. So we've just encouraged your friends to give you feedback, and how big are those effects? So the partial R squared for these instruments is 10 to the negative 5. So that maybe answers your question, right? So so in every substantive sense, these are the weakest instruments you've ever seen, perhaps. Right? But they're weak by design. We, in fact, design the instruments to be in this substantive sense really weak, right? But because we have a very large sample size, our first stage, F for the instruments, is still over 500.
Wait, so you designed them to be weak. If you could have made them stronger, you would have been happy to do that, but you'd be too intrusive. Is that the point?
Yeah, potentially, right. So if we start paying Jamie's friends to comment on his post, maybe we get some reactance. Maybe Jamie finds out about this other ways, etc. So certainly, like really kind of major interventions have disadvantages, and so this feather touch one is right. Now, I think if you weren't able to have such a large sample size, you'd have to make sort of trade-offs here and say, okay, if we use a little bit of a heavier nudge, is this going to produce reactance? Is this how much less plausible is this going to make our exclusion restriction, et cetera? Is this going to change our estimand from being something that's like very close to the marginal treatment effect? Because the local average treatment effect is going to be a constant piecewise approximation to the marginal treatment effect. Um, uh, and is it going to be something very different? Is this now going to be talking about, what are the effects of peer feedback under that would occur only under very different policies? So those are the kind of trade-offs involved. So part of the case that I'm going to make here is saying really that like a lot of times people think, okay, what is big data useful for in the social sciences? So one answer is high dimensions, right? That either I'm trying to estimate high dimensional treatment effects or I'm trying to do high dimensional adjustment. And so I really need big data. Otherwise, if I need big data, then it means I'm finding treatment effects that are tiny and unimportant. But here, these aren't the effects that we're actually trying to estimate. We're just using this first stage as a way of estimating the second stage effects of receiving feedback, which can be quite substantial. And by using this lighter and lighter touch, by using this intentionally weak, not in the statistical sense, instrument, that makes this potentially more plausible. So,
Well, it's incredibly interesting. You definitely need the observations in order to estimate it, given the light touch. So roughly speaking, there's 50 million observations, and the 2,000 or 25,000 or whatever it is, where the touch had an effect is where you're doing your experiment.
mm-hmm.
So probably you should study the characteristics of that small subset, because it must be really small, right? By definition,
Yeah,
right?
yeah, potentially. So one of the things that's a little bit different here, right, is that the behaviors of interest are not at the ego level are not just a binary behavior of whether my friends gave me feedback or not. We're going to look at how much feedback I received. And so part of the reason that you have this small r squared is that even on the log scale, there's a lot of variation in how much feedback people receive. That's potentially hard to predict depending on whether they posted something high quality or low quality. And it's precisely that kind of unobserved heterogeneity that is why the observational estimators here would maybe be so misleading. But yeah, actually, it's something I'll show in a second. We use lasso first stage to see if there's a lot of heterogeneity in this first stage as well. Okay, so basically, this just confirms this thing that I declared was a fact earlier, which is that changing how this box is displayed does cause people to receive more or less feedback slightly. So now we're going to use this shock that we have to how much feedback people receive to estimate these effects. And just to clarify, since I sort of skipped over it real quickly, right? This is kind of the equations that we're interested in. The effect of D, the amount of feedback received on Y, and we're using as instruments for D this treatment assignment Z, which is the assignment to this peer encouragement. We have a whole bunch of covariates involved, basically some binary covariates indicating quantiles of some of the relevant variables. And then also we have 80,000 indicators for network clusters. We partitioned the network into 80,000 pieces. So we have these fixed effects. The main reason that we're going to include that is because actually our statistical inference strategy is going to try to be robust to dependence within those clusters and also adjacency robust. And so we thought we might as well add the fixed effects for them too. So, and like saying that we have a matrix that's 80,000 entries wide sounded kind of fun. So,
So on the previous slide, did you use just the always people or the always and sometimes people?
So here,
Sometimes encouragement.
yeah, so we have the conversation salience, which controls the display of posts that already have feedback. That's just a binary indicator. And then this is sort of from this main effects model. It turns out there's not really interactions between these two things on the multiplicative scale, at least. And so then, yeah, most of the action is coming from these two though sometimes encourage initiation, which essentially is opening that text box if the story's in the first position in newsfeed, has a small effect as well. But there's a lot of data in this condition. So
Are these relative to the baseline of norm? Is that what this is?
yeah, the baseline of low conversation salience and never encouraging initiation. That is always summarizing and not opening the text box. Yep. Okay. So now in the second stage, we're going to basically we're doing two-stage least squares. Use this variation that we produced in the amount of feedback received to estimate the effects of receiving feedback on subsequent ego behaviors. And so, sort of to put the rest of these effects in context, let's think about first just the effects on essentially reply behaviors. So if somebody comments on my post, one of the most direct effects should be that I might reply to them by writing a comment in reply or by liking their comment. And so we might think that these are the largest possible effects that you could observe are the effects on these sort of reply behaviors. So they give a context or a scale to the rest of the effects that we're going to estimate. And so we find that if somebody receives 10% more feedback, they produce 10% more comments on their own posts and 10% more likes on comments on their own posts, right? So that's sort of the upper bound of effect sizes that we should observe in this case. Now, the effects that we actually care about a bit more are those on posts and giving feedback to other people. And those are approximately just one order of magnitude smaller than these largest possible effects. And so if somebody receives 10% additional feedback, they give 1% more comments to other people, 1% more likes to other people, and a little bit less than 1%, about 0.7% more posts. That is, they produce, again, this behavior that got them sort of in this position in the first place, right? If we think of the feedback sometimes as functioning as a reward, they received a slightly larger reward, and they repeat the behavior more often. So this provides experimental evidence for this kind of virtuous cycle in content production, directed interaction, and consumption that's critical to communication technology like Facebook. Yeah.
I just I'm thinking about the compiler group here, and so this is it's very
Mhm.
small, right? It's a very small group. Basically, this really shows the small weak first stage, and it's a group of people that are influenced by this feathered touch, right? The people that would that are going to skip over things if they're kind of presented to them in this way, but respond if they don't. And are those is that people that have a lot of those friends is the egos that have a lot of those types of friends are the compliers in this experiment, I guess.
Right.
And so it's just are those normal people? This is kind of like the nearest point, which is is it if you were going to roll out these changes broadly, you'd have to think about how this generalizes to the population. And so I'm trying to think about whether or not those compliers are an interesting subset of the population.
Right. Yeah. So are these and it's can be a little messy talking about the compliers because it's really the peers who comply, and you have multiple peers. So right.
Whether your group of friends are it's whether or not my group of friends are compliers.
Right. Right. And you might think, for example, that if my friends are the type of people who are easier to nudge, then maybe I'm easier to nudge by peer behaviors, right? So you could wonder about what's the structure of, correlation of susceptibility to nudges and susceptibility to peer behavior in the network. That's, I think, a really good question. The other thing you asked about is, if we're going to roll out these changes more broadly. And just to clarify, I think the goal here is really estimation of these important quantities for a communication technology like Facebook, rather than comparing specific policies, because this really isn't going to tell us about the policy. Because the way this works, right, is that people are seeing a mix of posts expanded and not expanded in their feed. And if the policy we were considering were expanding everybody's posts, that obviously there's some important set of violations that would come into play as you start considering dramatic changes like that.
What I mean is that even if they want to learn about the science here, about how people make decisions and stuff like that, there's maybe a very small group. What kind of generalizations can we make about people from getting maybe more to the point, which is about people in general, or the way people use communication technology in general, from this group of people that are very small and are very unrepresentative in terms of how they actually use the platform.
Right. I think most of the variation is not so much in the people, but in the specific person post pairs, right? That this works for specific types of cases, right? So there may be certain posts that you would be induced to comment on by this change, whereas there's other posts that you wouldn't be. So I think there are you do worry about how representative this is. But I mean, I wonder compared with other quantities whether this is better or worse, because obviously something like an average treatment effect on the treated seems even more irrelevant here, given that would correspond to a version of the world in which no one gets any feedback. And I don't know, solve for the equilibrium there or something, right?
I just think, there's a couple of, like, one point is that you could, doing things like a body style, looking at what are the features of the compliance group to get some sense of how they compare to the overall group. But also in terms of, I think it's, if you're going to estimate a local average treatment effect, that's like, it's local. And so to what extent, to think about generalization from that, I think you're right that all of these things are local, but this is, as you're showing us, this is very local. And you needed 50 million people in orbit to get to the, and I'm not saying that's a feature of these kinds of designs, but I'm wondering about the generalization seems hard.
Yeah.
But the compliers aren't the target of inference, right? He's nudging people that aren't actually the people that he's looking for.
Right. So it's people that have compliant friends.
Right. So
right.
It's unclear, like, whether describing the characteristic of the compliant friends, what that would mean.
Mm-hmm. Yeah, so I think you can potentially look for heterogeneity in just the first stage at the ego level to say who are the egos who this encouragement, when applied to their friends, has large effects on the amount of feedback they receive. And so I have a couple things that may bear on this. So one is this kind of picture, which some people are very familiar with, these difference in ECDF plots, and for everyone else, maybe it's really confusing. But basically, we're looking at the difference in the cumulative distribution function for feedback received for each of our experimental conditions, where the baseline here is this low never case. And so if we contrast between lines of the same type but different color, that corresponds to different conditions in terms of encouraging initiation. And so if we look at, say, always encouraging initiation versus never encouraging initiation, a lot of the shift in the distribution is coming at the low end of the distribution. So as we would have expected ex ante, that this condition that applies to how posts are displayed when they don't have feedback yet is causing shifts in the lower end of the distribution of feedback received during this period, whereas comparing lines of dashed versus solid of the same color, like this case where we're comparing conversation salience high or low, whether the post, once it has feedback, is expanded, that's causing a shift more in the middle part of this distribution. And so actually the sort of the compliance profiles are going to be quite different between these two cases. And so for our preferred model with the main effects that combines both of these, this is the two-stage least squares weighting function that is implicit in two-stage least squares. That is, this tells us something about the average causal response that's identified by this. And so if you compare this function to the PMF for how much feedback people receive, so you just divide these weights by the fraction of the population that actually receives that amount of feedback, we see that this ends up downweighting, part of this low end of this distribution and slightly upweighting this middle part of the distribution as well. So that's sort of one answer to what's being identified here. But the fact that actually we have these two different encouragements and that they shift different parts of the distribution might prompt us to look for some of that heterogeneity. And so here I'm plotting the same results that you just saw in black, but also estimates that arise from just using one of those encouragement factors or the other. So either only using conversation salience or only encouraging initiation. And so actually for our main estimands of interest, these estimates are indistinguishable. Now, the encouraged initiation ones are a little bit underpowered on their own. And so, we maybe can't detect all differences. The other thing that we do is we consider a lasso first stage where we interact all of these experimentally assigned factors with a bunch of covariates that include essentially lagged versions of the outcome and of the treatment to try to exploit heterogeneity in the first stage. And actually, those estimates pretty much coincide with the others, except they're maybe slightly more precise. There doesn't seem to be, at least on the log-log scale, a ton of heterogeneity, either in the first stage or just sort of in this estimation overall, which might make us slightly more confident that we're estimating something that at least approximately is general to these two different types of encouragements.
You probably can't make this information available for cause of confidentiality. But don't you want to basically say that, well, the people that can be pushed around are in South Carolina, and you can't move anybody in New Jersey or something like that? And then, so basically this analysis really applies to South Carolina.
Mhm.
That's sort of that's the kind of substantive conclusion that you look for, right? Because that's what you're estimating, right?
Right.
It's
I think that my intuition, at least, and from what we've looked at, is that this is slightly more general than that, and that sort of anyone could have a complier friend at any moment, right? Um, uh, yeah. But that a lot of it is maybe more like post-level heterogeneity. So I think those are definitely interesting questions with respect to how you might target the specific intervention. So if we think of this not as an encouragement that we're using for research purposes to estimate these effects, but instead we're trying to use it to target the intervention, we'd really care about the efficiency in that way, because there's essentially a lot of trade-offs going on in how much space all these different posts should be using.
What's the percentage of people that have somebody who would comply with this light touch in the population?
Mm-hmm.
Do you know that? Can you estimate that?
Yeah, well, so that's sort of this picture here overall, right? So,
Can you make it into a number for us?
right, so that would be, 0.2% would be, for example, the difference at this point. Here, there's a larger difference at a different part in the distribution. So, here the fraction of people who under the lowest treatment condition versus the highest treatment condition is almost 0.6% are being moved across this boundary. So,
But this isn't like a minimum thing, right? It's like it's not just like you have one person, you have one compliant person puts you over the edge. It's like it's scale. It's like this is the D is continuous.
right,
So
right.
So
more complicated.
My
Yeah.
hunch about your emphasis on the sort of post-level differences rather than individual differences is definitely. I mean, humans are a social being, right? And that's. But I think the sort of programmatic thing on the post-level heterogeneity would be something like, are the effects being driven by surprising people commenting on me?
Mm-hmm.
Right?
Yeah.
Like, someone that usually doesn't
Yeah.
now does. And it's
Yeah.
that sort of heterogeneity then that is, because that's going to be, if the whole point is for Facebook to promulgate more social interaction, which is kind of scary, then raising those things and like Chris's comment about newsfeed is then exactly the sort of thing that would come out of this. So that would be the programmatic intervention.
Mm-hmm. Right, and so a lot of our interest in terms of next steps is thinking about heterogeneity in the ties that are involved. And so we have versions of this design where, as I mentioned earlier, we're randomizing specific edges, and then you can think about asking about, okay, what's the effect of comments and likes separately from different types of friends? Yeah.
Is my conjecture right that the surprising comments drive more of this, or is it the flip side is
Mm-hmm.
my best friend is what really pushes me to become more social, but the other
Right.
is, my distant cousin. I don't
Right. So I think some of the intuitions from also prior work suggest that one of the things we should watch out for here in the case of comments is potentially negative peer effects. That comments could produce a kind of context collapse. So if you get this person who normally doesn't comment on your post to join in commenting on your post, that might not always actually be a good thing. Whereas perhaps them liking your post might just sort of generally be good. So one of the things we're doing in some of this work is also trying to encourage likes and comments separately. These encouragements produce likes and comments basically in the same proportion, essentially. We thought they might do that somewhat differently, but they didn't. So you can use a different sort of encouragement that might specifically nudge likes versus nudge comments.
Sorry, I have to leave for a meeting. I
Yeah.
apologize. What's interesting about this design is that in some senses, the time it takes to, in some senses, you're biasing yourself from getting results, because the time it takes me to read through the posts is decreasing the time I have available to then do something myself active on the platform.
Mm-hmm.
Right? So that's, I don't know, I mean, right? Because it's in some senses, like your actual encouragement versus the control of just having a summary statistic of the number of likes is actually giving me less time to then do the pro-social thing that you want me to do.
Mm-hmm.
Right? So So imagine you train people to be able to read through posts more quickly or something.
Yeah.
You'd actually identify an even stronger effectiveness.
Right. So it's interesting to think about, yeah, what would happen if you really changed the policy at the viewer level? And certainly, as you can imagine, that's something that Facebook thinks a lot about, especially on much more space constrained devices, right? So this was all web in 2012. And you may notice that the status quo on web, on Facebook, is very different than on mobile in terms of how much feedback gets expanded because of just the limitations of space and what you're training people to do, et cetera. Yeah.
Is there anything we can learn about like, the affect of commenting? Like whether it's like hey, good job, or like I hate you, Trump.
Mm-hmm.
Like,
right.
Can we learn something like that?
I think that's an interesting question. So we looked at just a coarse measure of how much are these comments like other comments in length, for example, and they're pretty similar. Most comments are pretty short, but not so much in the affect aspect. I think you would need some, if you really wanted to study that, you would need an encouragement that also produces comments of varying affect. So, yeah.
I have a few questions. So one of the things it seems like you could do is you could actually turn your instrument into thresholds of you didn't get any feedback on your post to you at least got some, and then look at a binary instrument, which seems like it might be easier to understand what your effects were if you turned it into like carrying it into you got something versus you didn't get anything.
Right.
Because it seems like there's something very different about going from nothing to something versus from something to a little more something.
Yeah, I think there definitely is, and that is all sort of obscured away by doing a log-log model, which obviously is not even strictly defined in some of those cases, but it is if you add a small amount to it. But yeah, so some of this is going from 0 to 1. So I think that one idea would be you could imagine having a specification that goes from 0 to 1, and that so you have two endogenous variables. One is whether I receive at least one piece of feedback, and the other is just how much feedback I receive. I think I don't know whether we would have enough power for that in this particular design, but that's a good question.
So most posts get some sort of feedback then?
Well, so some of it is a question of whether you're thinking about this on the post level or the ego level. So most egos receive some feedback during this time period. But yeah, you might worry about some other sorts of measures, like what was the time to the first piece of feedback? What was the time to the first like? How long did my post go without receiving any feedback? So there's a lot of ways to conceptualize that, and that also highlights some of the contingency of what we're estimating here being wondering about who are the compliers. Also, some of the types of compliance we might really have going on here is people commenting earlier or slightly differently than they would have otherwise. So I think those are all kind of challenges for this sort of work.
And people are, and in a single web page, they're looking at potentially more than one of these experimental manipulations at once, possibly with contrasting user interface. Like something will be expanded and something won't.
Right.
Like, is there any thought on what that does cognitively? Like that seems to be violating independence assumption in some way of like one's expanded, one's not. Are you borrowing from this to post there? Are you seeing just a reallocation of effort?
Yeah, so I think that there are definitely some like set of violations going on here, and so though I think they're a lot less severe than in a lot of other settings where we'd care about estimating what would happen if everybody was treated versus nobody was treated. Whereas here we're really trying to estimate these sort of marginal pure effects. But we do in the paper we do some stuff designed to be robust to that sort of nuisance interference using randomization inference. Yeah, certainly there's potentially substitution kind of happening. Yeah. Okay, I think that's probably most of what I wanted to show. I was just going to follow up by sort of summarizing a little bit, is that basically we expect a lot of these network effects in communication technologies. It's often hard to identify network effects or peer effects. We think that peer encouragement designs, especially these ones that use these small and highly specific encouragements, are a really promising strategy, both in terms of power by using these specific encouragements, and also in terms of plausibility by using sort of feather touch encouragements, then we found substantial evidence of these kinds of virtuous cycles in the context of Facebook. One thing I want to mention is like, so I designed an experiment for this specific purpose. Why should we limit ourselves to learning from this one experiment? Actually, maybe there's a lot of experiments lying around that we could have used for this purpose. So Hal Varian says Google runs over 10,000 experiments a year, and I think you can imagine a lot of internet companies are similar. So in some of our ongoing work, we've been looking at essentially doing massive meta-analysis of existing experiments with the goal of potentially identifying peer effects. And so in a working paper that's available on arXiv with Alex Peshakovich, we use regularized instrumental variables regression on collections of hundreds of experiments in order to estimate peer effects. So, because one way of thinking about what we did in this experiment is essentially that we, in this sort of grouped or visual instrumental variables picture, we have these 6 experimental conditions that vary how much feedback people receive, and then we can see how those conditions are associated, the means of those conditions on this x variable are associated with the means of those conditions on the y variable. But you could imagine doing this with some much larger collection of experiments that was not necessarily designed for this purpose. Yeah, thanks for having me here, and thanks for your attention and interesting questions.